Welcome to the MKN universe. Today, we are breaking down the engineering architecture and operational capabilities of the Dassault Rafale. Modern aerial combat presents a saturated tactical environment. A pilot might need to evade an active radar lock, track an incoming bogey, and deploy a precision-guided munition at the exact same time. Legacy fourth-generation fighters manage this complexity through a multi-role philosophy. A multi-role aircraft executes different missions on different days. One day it flies as an interceptor, the next a ground bomber. Alag-alag din, alag-alag mission. The Rafale operates on a different logic, the Omnirole architecture. As seen in this diagram, it executes air supremacy, in-depth strike, and ground support concurrently on a single sortie. Ek hi udan mein ek saath kai alag-alag mission ko anjam dene mein saksham. Achieving this capability isn't the result of a simple software patch. It requires a complete bottom-up redesign of the aircraft's physical framework and electronic processing. Let's look at those first principles. We start with the physical airframe. To execute simultaneous mission profiles, the jet must lift a massive payload of diverse weapon systems without losing its aerodynamic agility. Looking at this specifications blueprint, we see the true engineering margin. The Rafale has an empty weight of 10.3 tons, but a maximum takeoff weight of 24.5 tons. It can carry nearly 1.5 times its own weight, an extreme aerodynamic advantage. Pushing 24.5 tons through the air at Mach 1.8 requires extraordinary propulsion. This cutaway shows the Snecma M88 engine. Each unit delivers 75 kilonewtons with afterburners, guaranteeing a 1-to-1 thrust-to-weight ratio. This raw muscle is governed by FADEC, or Full Authority Digital Engine Control, noted here on the performance breakdown. FADEC enables carefree handling. During extreme maneuvers, pilots can slam the throttle to max afterburner in under 3 seconds without the engine stalling. Without this automated engine safety, rapidly switching from a heavy ground strike profile into a defensive dogfight would physically overwhelm the platform. Thrust gets the aircraft into the combat zone. Survivability, its skin and shield, keeps it there. This breakdown details passive stealth. 70% of the outer skin utilizes radar-absorbing carbon fiber and Kevlar composites. S-shaped intake ducts obscure reflective turbine blades, and the gold-lined canopy traps internal radar waves. 70% bahariya avaran mishrit samagri se bana hai. Passive stealth reduces detection range, but penetrating heavily defended, contested airspace demands a much more aggressive defensive approach. This brings us to Spectra, providing a 360-degree detection shield against hostile threats. Its core advantage is active cancellation, Sakriya Raddikaran. It broadcasts tailored signals to destructively interfere with incoming enemy radar, acting as an electronic cloak. Utilizing active electronic interference rather than relying solely on stealth geometry, the Rafale functions as an electronic cloaking device, ensuring deep strike survivability. With the defensive shield established, we move to situational awareness. An Omnirole fighter in combat generates an immense volume of raw battlefield telemetry. The primary active sensor, the RBE-2 AESA radar, utilizes thousands of modules to map 3D terrain and track targets simultaneously. For passive tracking, front sector optronics and the Scorpion helmet identify heat signatures without emitting detectable radar. This creates a very critical human bottleneck. If a pilot manually monitors the ASA radar, optronics, and Spectra suite under fire, they hit task saturation and fail. The solution is data fusion. This schematic maps how radar, optronics, and EW streams feed a central processor. Data fusion synthesizes these feeds into a single tactical display. विभिन्न सेंसरों से प्राप्त डेटा को मिलाकर एक स्पष्ट स्क्रीन पर दिखाता है. Operating via NATO Standard Link 16, the aircraft also acts as a silent forward node, seamlessly sharing its process data with allied AWACS and destroyers. Data fusion handles the complex sensor feeds, allowing the pilot to focus purely on tactical decision-making. With the data processed and targets locked, we examine the claws of the aircraft, how it physically executes the strike. In this arsenal overview, we see the air-to-air configuration. It features the agile Mica interceptor, alongside the Meteor Beyond Visual Range missile. The Meteor utilizes ramjet propulsion to maintain peak velocity directly to the point of impact, creating an inescapable kill zone. For ground operations, the Precision Strike arsenal includes the modular AASM hammer and the Scalp EG. The Scalp is a 1,300 kilogram stealth cruise missile engineered specifically for deep strike bunker busting. This payload blueprint maps the sheer volume of firepower. The Rafale utilizes 14 hardpoints for up to 9,500 kilograms of external load. For dogfighting, an internal GAAT 30mm revolver cannon lays down 2,500 rounds per minute. These payloads adapt to specific operational demands across 3 hardware variants, shown here the single-seat Rafale C, the twin-seat B variant, and the carrier-based Marine variant, the Rafale M. This massive adaptable loadout proves the Omnirole capability. A single jet can carry meteors to clear the skies and scalps to destroy a bunker in one continuous sortie. Modern fighter airframes are engineered to operate for decades. To remain viable, the architecture must support continuous software and hardware upgrades. This timeline maps the Rafale's evolutionary standards. The platform is advancing from the F3R baseline into the deeply networked F4 standard. Looking ahead to the 2030 F5 standard, it introduces advanced AI, giving the Rafale capacity to autonomously command loyal wingman stealth combat drones. Industrially, the platform maintains a significant global footprint. This map highlights its widespread operations, heavily supported by Make in India initiatives, where joint ventures produce fuselages and core components in Hyderabad and Nagpur. This summary slide brings the engineering profile together. The Dassault Rafale represents the technical standard for 4.5 generation aviation through its balance of agility, 9,500 kilogram payload capacity, and integrated sensor fusion. This performance profile effectively bridges the gap between legacy manned platforms and the impending era of autonomous warfare. Thank you for joining us on the MKN Universe. For a complete PDF breakdown of the technical schematics, check the link in the description. Subscribe for more engineering deep dives